Mars, our mysterious red neighbor, has long fascinated us. But standing on its surface, you'd face a brutal reality. The air is almost non-existent, 100 times thinner than Earth's, and made almost entirely of carbon dioxide. Without a spacesuit, you'd suffocate in seconds. Mars is also freezing. With little atmosphere to trap heat, daytime temperatures are frigid, and nights plunge below -100 degrees Celsius. Water is locked away as ice, making life as we know it impossible. Radiation is another invisible threat. Mars lost its magnetic field eons ago, so deadly cosmic rays constantly bombard the surface. Prolonged exposure would damage DNA and raise cancer risks, demanding heavy shielding for any human outpost. Gravity is only a third of Earth's. While you'd feel lighter, long-term effects could mean muscle loss and weaker bones. Astronauts on the ISS already struggle with these issues after just months in space. Mars combines thin air, deep cold, relentless radiation, and weak gravity, a cocktail of challenges for any would-be colonist. Surviving here isn't just hard, it's a fight against the planet itself. Any hope of calling Mars home means overcoming every one of these obstacles. The dream of living on Mars is inspiring, but the reality is a world that's deeply hostile to life. Every step forward will require technology, ingenuity, and determination. Mars is not waiting for us, it's daring us to try. The question isn't just can we go, but can we survive? The answer will define the next era of human exploration. For now, Mars remains a world of peril and promise. How could we ever make Mars livable? The answer? Terraforming, remaking the planet to resemble Earth. The first step is thickening the atmosphere, trapping more heat to warm the planet. Mars' polar caps hold vast stores of frozen carbon dioxide. If we could release it, we'd kickstart a greenhouse effect. As the planet warms, water ice could melt, forming rivers and lakes, crucial for life. The landscape would shift from red and barren to dynamic and potentially habitable. But a warm, thick atmosphere isn't enough. Humans need oxygen. We might introduce engineered microbes or plants to convert carbon dioxide into oxygen, slowly transforming the air. This process would take centuries, even millennia. Terraforming is a marathon, not a sprint, a planetary project on a scale we've never attempted. Each step would bring Mars closer to being a second Earth, but every stage is a massive challenge. The vision is bold: blue water, green life, and breathable air. But the path is long, uncertain, and demands patience across generations. Still, the blueprint is there, waiting for us to try. The transformation of Mars would be humanity's greatest engineering feat. The question is, do we dare to begin? Dare to? To start terraforming, we need to heat Mars and fast. One idea: giant orbital mirrors focusing sunlight onto the polar caps, releasing CO2 and thickening the atmosphere. Another, factories pumping out super greenhouse gases, far more potent than CO2 to trap heat. Or, in a dramatic move, redirecting ammonia-rich asteroids to crash into Mars, releasing heat and greenhouse gases in one explosive event. Each method is ambitious, risky, and far beyond our current technology. Building space mirrors, running planet-wide factories, or steering asteroids are all monumental tasks. But these concepts give us a framework for what's possible. They show that, at least in theory, Mars could be transformed. The challenge is enormous, but the laws of physics don't rule it out. The real question is whether we can turn theory into reality. For now, these ideas remain blueprints for a future only imagination can reach. While terraforming is a distant dream, today's Mars missions are laying the groundwork. Rovers like Curiosity and Perseverance analyze rocks, search for water, and hunt for signs of past life. Instruments like MOXIE have already made oxygen from Martian air, a crucial step for future explorers. International partnerships from NASA to ESA and private companies are pooling knowledge and resources. Every mission maps the surface, tests new tech, and teaches us how to survive on Mars. These robotic pioneers are gathering the data we'll need for any future transformation. The more we learn, the better we can plan. Today's science is tomorrow's foundation for life on Mars. The journey has already begun. Even with bold ideas, terraforming Mars faces daunting obstacles. Mars lost most of its atmosphere to space, and there may not be enough CO2 left to warm the planet. Without a magnetic field, any new atmosphere would be stripped away by solar wind. Creating an artificial shield is a colossal challenge. The timescales are staggering. Centuries to warm the planet, millennia for breathable air. And if life exists on Mars, do we have the right to change it forever? These are questions we must answer before we reshape a world. For the next century, Mars will remain a place for small, self-sufficient outposts, not a second Earth. Early habitats will be sealed domes or underground bases, shielding us from radiation and cold. We'll recycle air and water, grow food in hydroponic farms, and use tech like Moxie for oxygen. Life will be confined to bubbles of Earth, with astronauts venturing outside only in advanced suits. The focus will be on survival, science, and learning how to adapt. These outposts are our laboratories for a multi-planet future. The dream of terraforming will live on, but for now, we must learn to survive before we can transform. The first step to a new world is changing ourselves.